This is the second video in a series on simplifying algebraic fractions. Last time we looked at simplifying algebraic fractions like 6b over b, and we saw that there was a b in the top and a b in the bottom, so we could cancel them out to just be left with 6. We moved on to more complicated ones like 6ab over 3ab squared, and there we saw the 6 and the 3 cancelled out to leave 2 on the top, the 2 a's cancelled, and the b on the top cancelled with one of the b's on the bottom, and that left us with 2 on the top and b on the bottom. This time we're going to look at slightly more complicated algebraic fractions, in which we have to factorize the expressions involved in the numerator and denominator before we can cancel. Factorizing is simply finding the factors within an algebraic expression, and so we are actually doing exactly the same thing. So if we have an algebraic fraction which includes any additions or subtractions within the fraction itself, we must first factorize the expressions to find the common factor. So for example, in this fraction we have an addition on the top and an addition on the bottom. So the first thing we must do is factorize both the top and the bottom of the fraction. So on the top we see that there is an a in both parts, so we factorize out the a and we get left with 2 plus a. On the bottom we see that 4 goes into both parts, so the 4 goes out the front of the fraction, and inside 4 times 2 is 8, and we need an a. Now we have our common factor on the top and the bottom. The 2 plus a appears on both the top and the bottom, and that leaves us with just a over 4 as our final answer. So now this example, 3x plus 6 over 3x squared. So again, we have an addition on the top, so we're going to need to factorize first. 3 goes into both 3x and 6, so we factorize out the 3, and we get left with x plus 2 inside the bracket. And on the bottom, there's no addition or subtraction, so we can't factorize, so we just have 3x squared still. But now on the top we have a 3, and on the bottom we have a 3, so they can cancel out, giving us a final answer of x plus 2 over x squared. In this example we now have two letters. We have 4ab plus 8a squared all over 12a. We're going to do the same thing. We're going to factorize first. So on the top we can factorize out a 4, and we can also factorize out an a. And then in the brackets that leaves us with a b in the first term, and then 2a in the second term. And on the denominator, 12a cannot be factorized as it is a single term. But now on the top we have a, and on the bottom we have a, and also on the top we have 4, and that cancels with the 12 to leave us with 3. That gives us a final answer of b plus 2a over 3. The next example we have 2x plus 2 over 5x plus 5, and again we have additions within the algebraic fraction, so we're going to factorize. In the top we can factorize out a 2 to get 2 brackets x plus 1, and on the bottom we can factorize out a 5 to get 5 brackets x plus 1, and straight away we see there is an x plus 1 on top and an x plus 1 on the bottom, giving us a final answer of 2 over 5, or 2/5. And in the final example we have x minus 1 squared all over 3x minus 3. Now the temptation here is to multiply out that x minus 1 squared. Normally this is a really useful thing to do, but when we're dealing with algebraic fractions we actually want the factorized form, so it is more helpful to have it within the brackets. However, we are going to write x minus 1 squared as x minus 1 times x minus 1, just to make the next step a little bit clearer. And then we can factorize the bottom. 3x minus 3 factorizes to 3 brackets x minus 1, and now we see there's an x minus 1 on the top that cancels with that x minus 1 on the bottom, leaving us with a final answer of x minus 1 over 3. So when we're dealing with algebraic fractions that have additions or subtractions within the fraction, that is either a plus or a minus on the top or on the bottom of the fraction, the first thing we need to do is try and factorize each expression and then look for common factors, either numbers or sometimes expressions within brackets, that we can cancel to get our simplified algebraic fraction.